In this video, we're going to look at operations on functions as well as composition of functions. In your problem, you'll be given a couple of different functions. Usually they're labeled f of x and g of x. Excuse me. Go with your intuition on the add, subtract, multiply, and divide. For example, the addition of f and g just tells us to take the like terms from each function. Like, for example, function f is 3x minus 5. Function g is 4 minus x. If you're just adding, you can let go of both sets of parentheses, and that's going to give us 3x minus 5 plus 4 minus x. And when you combine like terms, 3x minus x, that's 2x. And negative 5 plus 4, that's negative 1. And you have your answer. That's the sum of those two functions. Excuse me. And that is basically how you would add two functions together. You identify their like terms and add them together. Now with subtraction, it works pretty much the same way. You will have to be careful when you subtract. So we've got function f minus function g. That gives us 3x minus 5. Careful here. Minus 4 plus x. You have to reverse those signs. Okay, so we've got 3x plus x, that's 4x. Negative 5 minus 4 more is negative 9. So 4x minus 9. Whoops, try to write that a little better. And we have another function. That function represents the difference of the two original functions. For multiplication, because f and g both contain two terms, we'll multiply that out with the FOIL method. First times first. Outside terms, 3x times negative x. Inside terms, negative 5 times 4. And last terms, negative 5 times negative x. Combining like terms and reordering, we're going to get a negative 3x squared plus 17x minus 20. And that is the function that represents the product of f and g. In division, you basically just pay attention to which one's on top, f over g, and just write it as a rational function. F over g. And that's pretty much it. You don't actually have to divide them out, just stack them as a fraction. It is a courtesy and may not be required online in your homework, but as a courtesy, we need to say x can't be 4 because that creates a zero denominator. I don't think your homework requires you to do that, but it is a courtesy. Now with composition, you're going to see an open circle. This is like a fifth operation. We've just done add, subtract, multiply, and divide. When you see an open circle, that is composition, and what we'll do is collapse that notation down. And this is what we're going to solve. G of x is 4 minus x. So we're going to replace g of x with what it's equal to, and then we're going to place that into f. Well, f is 3 times x minus 5. 3 times our substitution minus 5. Well, that's equal to 12 minus 3x minus 5. Which is equal to negative 3x plus 7. Another function. And then, as you guessed it, G circle F, or may not have guessed it since it's brand new. Let me write that a little neater. You're going to actually plug F into G. So this will collapse down into G composed of f of x. F of x is 3x minus 5. Now we'll substitute that into G. Well, G is 4 minus whatever we substitute, which is 3x minus 5. And I'm about to run out of room, so if you distribute the negative, you get a negative 3x plus 5, add that 4 to it, and you get negative 3x plus 9. Plus 9. On the second example, we're going to look at operations and composition. This time with operations with numbers substituted in. Our first example, we have f times g of 4. Now these operations, the add, subtract, multiply, and divide, you can do substitution separately. Now what I mean by that is you can calculate f of 4 and multiply the value of that with the value of g of 4. Now we go to function f, it's x plus 3, so f of 4 is 4 plus 3, and that's 7. G of 4 is 4 squared minus 2. That's 16 minus 2, which is 14. And what's the product of those two? 98. Plug a number in, you get a number out. Maybe we're asked to set up the division. Well, that's going to be f of 0 over g of 0. F of 0 is 0 plus 3. G of 0 is 0 squared minus 2. If your fraction will divide out or reduce, you're expected to divide it out and reduce it. If not, don't force it. Negative 3/2 is just fine. I modified the bottom two examples if you happen to see a change in the video. Composition, you have to be careful setting these up. Just like we did on the first example, we're going to collapse this down. F of g of 3. Function g is x squared minus 2. So that's going to be g of 3, that's 3 squared minus 2. 9 minus 2 is 7. Now we go to function f. F is x plus 3, so f of 7 is 7 plus 3, which is 10. And that's our answer for this composition evaluated at 3. The next one, we have g of f of 1. Well, f of 1 is 1 plus 3, that's 4. G of 4 is 4 squared minus 2. 16 minus 2, that's 14. And so that's our second composition evaluated at 1. Okay, our last example for this video, we have function f defined as negative 4x and g of x defined as x plus 5. The first composition, when we collapse it down, is f of g of x. Okay, g of x is x plus 5. So we're going to calculate f of x plus 5. Okay, so function f is, we're going to take negative 4 times whatever the substitution is. In this problem, it's x plus 5. And that is equal to negative 4x minus 20. Clean that up a little bit. There we go. Okay, very good. G composed of f, we collapse that down. G composed of f. F is negative 4x. If we substitute negative 4x into g, then that's going to be negative 4x plus 5. You simply replace the x and g with negative 4x. Now the bottom two are kind of weird to look at. It's f composed of itself. Let's go ahead and collapse it down like we have been doing. Function f is negative 4x. If we plug f into itself, then that is negative 4 times what used to be x is negative 4x. We substitute it into itself. Well, that makes a positive 16x. And then g composed of itself, g composed of itself, g of x is x plus 5. So if we plug x plus 5 into the variable of g, that's x substituted plus 5. These are very difficult to look at. But anyway, the variable of g gets all of itself again, so that's x plus 10. Okay, so just be careful. I recommend the collapsing down and substituting. It doesn't hurt to write out a little extra just to make sure you get the problem done accurately.